Of the reference angle and the reference triangle. And I asked you to take a look at A on your own. We had to first draw the actual angle and standard position. And then I want you to identify the reference angle. And then draw this, what we call reference triangle. So let's do part B and C together. And I'll let you try the ones underneath on your own. Okay? So let's take a look at part B. And I'm going to ask you to first draw the angle and standard position. So here we go. So of course you always start on the initial arm. Okay? And then you're rotating which way? Clockwise or counterclockwise? Going with a positive angle here. Clockwise. Good. So here we go. Clockwise. Oh, good. Counterclockwise. Thank you. Theta equals to 60, right? Counterclockwise when it's positive. Thank you. So my question to you now is, well, how do we calculate the reference angle here? Now, using the definition, which is still on the screen, the acute angle between the terminal arm and either side of the positive or negative x-axis. So here's my terminal arm. I'm going to put in green. Which one should I use, the positive side or the negative side? Positive side, right, because I want the acute angle. So notice, in this case, this 60 degrees is also the reference angle. Okay? It's the same. Also the reference angle. And now if it says, ask you for the reference triangle, I'll do that in purple. The reference triangle is just the acute triangle that contains this reference angle. So, of course, the reference triangle would be this one here. Okay? So that's your reference triangle. Everything is in quadrant 1. Okay? Let's try the next one here. Okay, I'm going to ask you to draw in the angle 250 first. And then let's see if you can identify the reference angle and then also the reference triangle. Okay. So let's do the actual angle and standard position. So here we go. Starting at the initial arm, rotate 250 degrees counterclockwise. So that's right about here. So there's my angle 250. Okay. And then now, once again, I'm going to ask you to find the reference angle. And if you're not too sure, look at your definition again. It's the angle created by the terminal arm and either the positive side or the negative side of the x-axis. In this case, which one would you like to use? Yeah, the negative one here. So here's your reference angle. Okay, and how do you calculate the reference angle in this case? Well, seems like the whole thing is 250. Up to this line, which is the x-axis, is 180. So my suggestion is this is 250, take away 180, or 70 degrees. Okay? And then last but not least, the reference triangle is right here. Okay? Okay. I'm going to give you a chance now to try the ones underneath, please. So I'll give you a few minutes to do this, and then we'll take a look together. All right? So try those ones. Let's record, yeah. So here are the answers to D, E, and F. Okay, so double check your work with mine. Notice all three of these standard position angles have the same reference angle, right? 30 degrees. But notice they can be in different quadrants, all right? Now, what I'd like to do right now is just to summarize the relationship between theta and theta r in each quadrant, okay? So hopefully this will give you a good way of figuring out the reference angles, okay? Now, I've got 4 different pictures here, so let's label this as quadrant 1, okay? And then I'll label this picture for quadrant 2. So please write this in. Quadrant 3, and also quadrant 4, okay? And I'm going to draw standard position angles in each one of these quadrants. And then I'm going to ask you to help me figure out the relationship between theta and theta r. Okay? So let's draw them in. Okay, here's my first theta. And I'm just drawing them randomly in the quadrant somewhere, okay? Theta. Theta. And in quadrant 4, somewhere like this. Theta. Okay, so just draw them in first, please. And then I'm going to ask you to think about, how is this angle theta related to theta r, which of course stands for the reference angle. Okay? Theta r is the reference angle. Okay, let's look at quadrant 1. Where's my reference angle? Well, think about the definition of a reference angle. I'm going to use the terminal arm and the positive or negative side of the x-axis to make an acute angle. So guess what? Theta r is also the same thing, right? So in quadrant 1, I want you to say that theta is equal to theta r. Okay, that's the key thing for quadrant number 1. Now, how about quadrant number 2? Where is theta r? Well, here's my terminal arm. I'm now going to use the negative side of the x-axis this time. Remember, it always has to be an acute angle. So how would I calculate theta r by using theta? Sure, take 180 minus the theta, and that will equal to, yes, theta r. Very good. Okay. We'll take a look at quadrant number 3 this time. Same thing. Here's my terminal arm. I'm going to use the negative side of the x-axis for theta r. And can someone help me out? How can I find theta r when I have now theta in this case?
Theta minus 180.
Whoa, yes. Okay. Loud and clear. So theta minus 180 equals to theta r. Good. Okay. And the last one, same idea. Okay. Terminal arm, x-axis, acute angle. Help, help, help. 360, yes. So in this case, go the full rotation and then come back by subtracting the angle theta, and then you'll have theta r. Okay? So I hope this summary here helps you out to help you figure out how to calculate theta r. And if it doesn't, then sorry for wasting your time. Okay? Turn to the next page now. And you've got a different type of question, but yet somewhat similar. I'm asking you to determine the angle in standard position when this angle of 25 degrees now is reflected. Okay, so I'll do part A, and hopefully you can do part B and C. Okay, take a look. If I'm asking you to, first of all, draw an angle of 25, let's do that. I'm going to put this in dotted position, like dotted lines, since this is not the real angle that we're looking for. Here's 25. Agreed? Now, what does it mean when I ask you to reflect in the y-axis? I'm going to take this angle and stick it over there. So where does it become? Here is where the angle actually becomes. So this is the angle that I'm looking for. That's theta. And what's this tiny angle here equal to that I'm going to put in green? Yeah, but what's the actual measurement? Yeah, after the reflection, you know this is 25. Good. So can someone tell me what theta is equal to then? I heard it. What's theta equal to in this case? Standard position. So yeah, so just take 180, subtract 25, which is 155. Okay? All right, you try the next one, please. Part B and C. So once again, start with this angle, which is 25 degrees. And then I want you to reflect it this time in the x-axis. So then draw that in, calculate the angle in standard position. And the last one, same idea, start with this angle in 25, but this time reflect in both the y and the x-axis. All right? So try that on your own, please. Yeah, X and then Y. Okay, here's the answer for B, for those of you who want to double check. I'm reflecting this in the x-axis, so it goes down here. Yeah, really. And this angle is also equal to 25 because it's a reflection, they're the same. So I'm asking you for this angle theta, which would be in the fourth quadrant, 360 take away 25, which is, how about 335? Okay. And then the last one here, you have to reflect it twice. So you first do it in the y-axis, so you get the picture like in A. But then you got to reflect this green one in the x-axis, so it actually goes down here. So the actual angle I want you to draw for this one is here in the third quadrant. And of course, the angle theta is just 180 plus 25, 205. Okay? How many of you got all those? Yay. Okay. All right. Now, how many of you actually take physics right now? With Mr. Locke? Block. Mr. Marzouk? Mr. Louis? Okay. Now, since all of you are taking physics, that's great, because I'm going to show you something they're going to use in physics. Okay? In physics, they don't go, this guy traveled at an angle and standard position. Okay? They don't do that. Okay? They do stuff like this. They use directions, like east, west, north, and south. Okay? So often directions in physics are measured this way. And they'll write it like this, n 35 degrees w. Now, what does that actually mean? Okay? This is what it means. Okay? It says, to draw the angle, you start from n. What's n? North. Okay? So you start from due north. And then you measure 35 degrees towards, and in this case, because it says w, west. Okay, now, let me show you how I will actually draw this angle. Okay? We're going to start from north. So where's north? That's this piece right here. This is north, right? There's north. So I'm starting north. And then measure 35 degrees to the west. So to the west means going which way? To the right or to the left? Right. Remember, west is here, right? West, south, east. So take your angle and rotate it to the left. 35 degrees. Okay? And this angle here that I'm going to highlight in red is what we call n 35 degrees w. Okay? That's what it is. Now, I am teaching you math, so I don't like that. If I asked you to tell me the equivalent angle in standard position, what would you tell me? I heard it, 100 and what? 125, good. How did you get that? Well, remember, for an angle in standard position, you are always measuring from the positive x-axis, and you're rotating until you get that terminal arm. So in this case, that would be a 90-degree angle, and you're going to add to that the 35, which is 125. Okay? So what I'd like you to do now is practice actually drawing these angles using the physics way, right? North, angle, east, or whatever. And then translate the physics angle into the angle in standard position. Okay? I'll try one more with you together, and I'll let you try B and C on your own. Okay? So, let's take a look at number 4. Draw each angle on the Cartesian plane, then express the direction as an angle in standard position. So here we go. NATE. Where do I start? Good. Start north. And then in this case, which way do I rotate? To the right or to the left? I'm going east. To the right. So notice I'm going to now rotate, and I want to rotate 80 degrees. So what is that? 10, and then 20, 30, 40, 50, 70, 80. So imagine the rotation, and it looks like it's about here. Oops, that doesn't look very good. Let's do about here. Okay, and this whole angle that was rotated eastwards is 80 degrees. Okay? So this angle here that I'm going to highlight in red once again is north of 80 degrees east. And now what would the standard position angle be then? Yeah, it's just here's your terminal arm, here's your initial arm, there's my theta, it equals to 10 degrees. Okay, try B and C please, on your own. Answers now, for those of you who have got it. South of 40 west. Start south. So go downwards, right? And then 40 degrees to the west. I guess you're going to the left. And this angle here would be south of 40 W. Which means where is your standard position angle? Well, once again, we start from here and we're rotating like this. What did you get as your answer? Is it 230? Yes. Good. And the last one, going S, then 15 degrees to the east. We'll go this way. So there we go. Here's our angle. This is S15E. And then, of course, if you want the angle in standard position, you're measuring like this again. So theta equals to 285? Okay. Good. Okay. Ladies and gentlemen, this section is kind of weird because it has a big break now, okay? And then the next topic is a little bit odd, but it doesn't really relate to this stuff from above yet. I will hopefully show you this stuff, and you'll be asked to do, I think, one question related to this in your homework, so it's not too bad. Okay? Okay, ladies and gentlemen, back to trigonometry from grade 10, or even grade 9, or grade 8. What's that favorite phrase you remember? Yes, SOHCAHTOA. Now, why is that phrase so important? So you can SOHCAHTOA? No, so you can solve for right angle triangles, right? That too. Now, before I actually ask you to write out the ratios here, you need to be able to identify the sides of a right angle triangle. Okay? H is the longest side. Good. So we call the hypotenuse the longest side. Sometimes we use letter H or HYP. I don't know. It's up to you. Okay? Okay? Hypotenuse. 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 Sorry. Okay? Now, let me call this angle down here the theta, or the one we know. Okay? Now, if that's the one we know, how do we label the other two sides of the triangle? Yeah, which one's adjacent, which one's opposite? Opposite is always one opposite the angle or across the angle. Sure, so across from the angle is always the opposite side. And we'll call that OPP as short form. And of course, the last one is the adjacent, and that's the one that is next to the angle, but not the longest side. And then we'll use the abbreviation ADJ. Adjacent. Okay. So what's SOHCAHTOA stand for? Well, S stands for sine. So sine of an angle A is the same thing as the length of the opposite side. So I'll just write down OPP divided by the length of the adjacent side. That's ADJ. Okay. Similarly with cosine, adjacent over hypotenuse. Ah, thank you. You are listening. Opposite over what? Thank you. Don't blindly copy things down. So, S-O-H, okay? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And last but not least, tangent is? Over A, or opposite over adjacent. Good. Okay? Now, I want you to keep these ratios in mind as we look at two what we call special triangles. Okay? And those two special triangles will appear on your back page.
We did that last year too.
Yeah, you did this last year too. Yes, Derek.
For example, when you're trying to find theta, will theta ever be over 360 then?
No. Angles in standard position right now for grade 11 is just always between 0 and 360. Okay, let's turn the page. Ah, here we go. I'd like you to do this for me for special triangle number 1. Draw a square. There's my square. You do yours too. Mine's really good, right? Thank you. I have magic. Okay, now, ladies and gentlemen, shh, quiet please. Your square has side length of 1. Okay? But I want us to create a right angle triangle. So what shall we do? How about let's cut this in half?
That way.
That way. Okay, so do that please for me. Okay. Okay. So, 45 degrees is one of the angles down here. 45 degrees is also this angle up here. And then I guess my question to you is looking at this, whoa. Sorry. Looking at this triangle, okay? I want us to try to find the ratios equal to sine of 45, cosine 45, and tangent 45. So underneath here, I'm going to draw this again. So this is 1. This is also 1. This is 45. Now, ladies and gentlemen, I don't have a side here. I'm missing a side. What's the length of that missing side? You forgot. Yeah, so remember this missing side here? You can use Pythagoras. 1 squared plus 1 squared equals to, I don't know, hypotenuse, I'll say, squared. So, of course, that equals to root 2. Okay? Good old Pythagoras from grade 8. Okay, help me out, somebody. What's sine of 45? Yeah, 1 over root 2. Okay, remember, opposite over hypotenuse. 1 over root 2. How about cosine? Also the same thing, 1 over root 2. Right? Adjacent, which also is the 1 over root 2. What about tangent? 1 over 1, just equals to 1. Okay? Now, ladies and gentlemen, for those of you who remember from last year in 10 honors when we did the rationalizing the denominator, remember how I said sometimes it's not nice to have a square root in the denominator? And to get rid of that, what did we actually do? We did something like this. We multiplied both the top and the bottom by root 2. Okay? And the rationale for doing this was it's really hard to divide by a big long decimal, but it's easy to multiply by it. So this becomes what? 1 times root 2 is just root 2. And how about the bottom? What's root 2 times root 2? That's also 2. Good. So sometimes you'll see people write cosine of 45 and also sine of 45 as root 2 over 2. Okay? Either or is okay with me. If you like the stuff in blue, that's fine. If you like the stuff in red, that's okay as well. Okay? Now, we're going to do the same thing with one other triangle, and then I'm going to tell you that you're going to have to memorize these ratios. You'll need to memorize them for this last question. You'll need to memorize them for next day, okay? So that's why I'm showing this to you now. All right, let's draw a equilateral triangle now over here. Is that equilateral? Oh, well. You can practice drawing an equilateral triangle. Don't get so lazy. Asian people work hard. What are you talking about? Okay. And two. The lengths of all the sides. Okay, let's focus back on the equilateral triangle, please. Why is it 2? Because I wanted nicer numbers. Okay, now, I want you to create a right triangle here too. So guess what? In this case, I want you to split it right down the middle. Okay, and now you might know why I chose the number 2 for the length of the sides. Because, what is the length of this side here going to be that I just highlighted in blue? That's right, it's half, so it's 1. And the side we don't know right now is the actual height here. Can someone suggest how I can figure that out? Pythagoras, you bet. So 1 squared plus h squared equals to 2 squared. And I think you could try to solve for h in this case. H is a root again. How about root 3? Okay. Just by using Pythagoras. And I'm going to ask you to copy that down in this picture here, and then I'm going to ask you to find the ratios. 1, 2, root 3. Okay, now what's the measure of the angles? What's the measure of this angle down here, the bottom one? That's 60, right? Equilateral triangle, 60 degrees. Good. What about the one on the top? That's right, 30. I cut it in half. So that's 30 degrees. Okay? If you can now write down the ratios, I'll ask you to try this, please, using the definitions of SOHCAHTOA. Start with 30 degrees first. Find the opposite, find the hypotenuse. Okay? Then do cosine. And then start memorizing this. And if you feel like this is really hard to memorize, I will show you a nice trick. Do you like tricks? If you make up a song, you can, but my trick is more like a pattern. Okay? What's sine 30? 1 over 2. Good. What's cosine 30? Root 3 over 2. What's tangent 30? 1 over root 3. Good. Sine 60, please. root 3 over 2. Cosine, 1 over 2. Tangent, root 3. Okay. Over 1, I'm sorry, over 1. Now, ladies and gentlemen, like I said, you're going to need to memorize this. Memorize. Okay? Now, either you can figure this stuff out by drawing these triangles, okay? Or you can memorize the ratios, or if you like this little table that I'm going to show you, you might want to use that instead. Okay? I am recording, yes. Okay, now, for those of you who want to use this little table, here's what I want you to do, okay? Get some blank space somewhere. Because I want to see where it comes from. Okay? Now, hopefully you find some space somewhere. Maybe you can take some space here, okay? Take some space on this side here, like this. Okay? And if you're wanting to find out a nice way of doing this, here, write this down. 30, 45, 60. You don't have to if you don't want to, but if you want to memorize this, you can. I showed some grade 12s today. They're like, oh, how come I didn't learn this before? I'm like, you never had me as a teacher. So, they missed out. Okay, see this little chart I'm making? Grid, chart. Okay, now, ladies and gentlemen, your chart needs to be this way, okay? You need to start with 30 and then go up to 60. You need to start with sine, then cosine, then tangent, okay? Because there's a reason. Or else it won't work, yes. Now, what's sine of 30 again? Go back to your numbers up top. What's sine of 30? 1 over 2. Good. I'm going to write that down in the table. 1 over 2. What's sine of 45? It's either 1 over root 2 or root 2 over 2. I'm going to use the root 2 over 2 one. Okay? Because I want to show you a pattern. And then what's 60 of sine? Or sine 60? Root 3 over 2. Good. Now, you know me, I like patterns because I can't really memorize stuff. But I can memorize patterns. Now, notice here. All of these ratios are divided by 2, right? Over 2, over 2, over 2. Now, you see how 2 of them have roots, but 1 doesn't? Let's make them all have roots. What's the equivalent form of 1 as a root? Yeah, root 1. Duh. So, I can just rewrite this as root 1 over 2. Same thing, right? Root 1 is the same thing as 1. Do you see a pattern now? Root 1, root 2, root 3, all over 2. Yeah, box it if you want. It's already boxed. Now, how about the other way for cosine? Let's take a look at cosine. Cosine 30 is root 3 over 2, okay. Cosine 45 is root 2 over 2. Cosine 60 is 1 over 2 or root 1 over 2. Now look at this. It's the same numbers, just backwards. Right? So sine goes up, increasing root 1, root 2, root 3 over 2s. Cosine is just the other way. Root 3, root 2, root 1, going backwards. And then what about tangent? Well, what's tangent of 30? That's 1 over root 3. What's tangent of 45? That's just the number 1. And tangent of 60 is just root 3. Now, how do you memorize these? Yeah. You don't memorize them. But I want you to notice, where's the 1 and the root 3 come from? Well, look, there's the 1 from the sine. There's the root 3 from the cos. Right? So, I guess I'm just taking this number divided by that number. Let's look over here. The root 3 over 1. Well, that's just the root 3 divided by the 1. How do I get the 1? Well, that's just root 2 over root 2. So notice for tangent, this is the same thing as just taking the numerator of sine and dividing it by the numerator of cosine. Now, why does that work? Because it just does. Well, let me give you a reason for this. Okay? Ladies and gentlemen, once again, how do we write down the ratios of sine and cos? Sine is defined as what over what, Sokotoa? I know, what's the something? Opposite over hypotenuse. Good. What's cosine equal to? Yeah, adjacent over hypotenuse. Now notice we've got hypotenuse in both of these things, but we're actually dividing. We're dividing a fraction by another fraction. So dividing is the same thing as multiplying by the reciprocal. So I'm going to take my first fraction, opposite over hypotenuse. Dividing is the same thing as multiplying by the reciprocal. What's the reciprocal of adjacent over hypotenuse? Hypotenuse over adjacent. So what does that become? They cancel, what do we get? Opposite over adjacent, which is lovely tangent. Yay. Okay? So that's why. Okay? Now, would you like a break now before I do the last one? Okay. Go ahead and take a quick break, and then I'll come back to do this one. For those of you who know how to do this one already, you can start on your homework, which is all this stuff over here. Okay? Take a 2-minute break. I still play, but I don't play very well. See, the problem is, I should pause this, okay? The problem, here's what I used to do when I played piano. Because I didn't play very well, I always had my metronome ticking. Have you seen those things? Tick, 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 tick. So here's this metronome, and it ticks, okay? And notice it says this. It swings from 30 degrees to 150 degrees. So let me draw a picture for you, okay? If here's my axes, right? Here's my x and y. I'm saying that the angle that it starts out at is 30. So here's where it starts, and this angle is 30 degrees, okay? But then what does it do? It swings. It swings all the way over to the left side over here. Okay? And the angle that it stops at is 150. So this is 150. Okay? So please draw this in your notes. Okay? I'll try to draw a better arc here. Okay? Oops. Try to draw a better arc if you can. Okay? Now, what am I asking you to find in this question? It says this. What is the exact, okay, now notice I said exact, okay, that's why you need that table, okay? What exact horizontal distance does the tip of the arm travel in one beat? Now, I asked you for the horizontal distance, so do not think that it's this curve that I drew in purple. It's not, because that's not horizontal. It's actually, yes, the straight line connecting the start and the stopping point. Okay, so the horizontal distance is this blue line that is straight horizontally done across. Okay? And 20 centimeters is the length of the actual ticking arm, so that distance in red here would be 20. So this is 20. Okay? Or that distance in green is also 20. Okay? Now, how can we actually solve this? Okay? You have to, first of all, be able to spot a right angle triangle. Okay? And I'm thinking, let's see if we can use this right angle triangle here. So I'm going to draw that out again, that triangle. I'm going to draw it out. Here's the blue piece. Here's the black piece. Here's the one in red, and that's 20 degrees, okay? I want to draw this out so you can see this a little bit better, okay? Now, can you figure out one of the angles for me in this case? Is there an angle here that you know? 60. This one here, 60. Good. Can everybody see why that one is 60 down here? Okay, because the angle that's complementary to it, right next door to it, is 30. 30, 90, 90 minus 30 is 60. Good. I'm asking you for the horizontal distance, so let's call this piece here x. Okay. What trig ratio should I use to help me solve for x? O and H represents sine. Good. So write down sine of 60 equals to x over 20. Now, by the way, in chapter 2, you will also have a calculator and non-calculator section for your test. And this would be a non-calculator question. Because what is now sine 60 equal to? You know this because you have the chart memorized. Root 3 over 2, Alex says. Thank you. So root 3 over 2 is now equal to x over 20. And you should be able to solve for x without a calculator. Two ratios. What should we do? Cross multiply. You bet. So 20 root 3 equals to 2 times x. Solve for x. What do we get? That's just 20 divided by 2. That's just 10 root 3. Good. Oh, right. We're not done yet. Don't forget this is just half of that horizontal distance. So you want the full horizontal distance, you have to double it. So therefore your full horizontal distance is just twice of that answer. So 2 times 10 root 3 is equal to 20 root 3. And this is what I call the exact answer, okay? Because there's no decimal, there's no rounding, it's the exact answer. All right? Okay. Welcome to knowing this table by heart. This is just one sample. On Thursday when you come, we'll need to do that a little bit more. Okay? Right, rest of the time is yours to do some homework.